Okay. Now, let's say you are being asked to solve a question in which you have been given 2 raised to the power of x greater than 3. So the question would mean solve this inequality. So we need to find those values of x that are going to result in 2 raised to the power of that number to be greater than 3. So in order to solve, like right now in the previous class, we solved these questions in which we had an equation sign, and we said that okay, we can apply log on both sides, and after solving this, we get one value. Now over here, we are going to get a range of values of x. The procedure is going to be same, but we are going to get a range of values of x. So how do we go about this? You It's the same way. You apply log on both sides, and I'm gonna take log to the base 10. That's why I'm writing lg. So I'm going to apply log on both sides. Applying the power rule will make this exponent come as a product. Okay. Now, what is lg to a positive number or a negative number?
Positive.
A positive number, right? So this is going to be lg3 divided by lg2, and if I solve this, I'm gonna get lg3 over lg2,
1.9.
1.59, 1.5849, so 1.58, I believe. So x must be
Okay.
greater than 1.58 so that this holds true. If x is greater than 1.58, then only 2 raised to the power of 1.58 would be greater than 3. If x is less than 1.58, then the sign inequality would be flipped. Now, do you remember that whenever we were solving inequalities and whenever we multiply or divide by a negative number, the sign of the inequality actually flips. So for
Yes.
example, if I have x equals to minus 0.5, let's say, and this was greater than 2. So if I divide 2 by negative 0.5, I'll have to flip the sign. That is one of the rule of the inequality. So I'm going to say x is less than minus 4. Okay. So over here, if LG, if let's say LG of that number, log of that number was to be a negative number, then the sign of the inequality is going to flip. Now you can understand it from here that if you have an exponential inequality and when you apply log, then this, okay, just a second. Yeah. So if we take log of, no, sorry. What I mean to say is if this number is a negative number and you divide or multiply the number by a negative number, then the sign of the inequality is going to flip. Okay, is that clear till here?
Yes, sir.
Okay. So let's try this. Solve the inequality 0.6 raised to the power of x less than 0.7. Okay, so we are going to have the same procedure. You are going to apply log on both sides. You can take log to the base 10 in this case. Try this out, and then if you need my help, I'm gonna help you.
I'm getting x is greater than 0.698.
X is greater than 0.698. Okay, let me solve this. I think you're right. So if I apply log on both sides, so log of 0.5, 0.6 is it a positive value or a negative value?
Negative.
Negative. So I'm going to divide log of 10 of 0.7 by this answer. Yes. So the sign is going to be flipped 0.698. Correct. Now you could, we have taken log to the base 10. Do you remember ln, natural logs? Natural logs are to the base ln, to the base e. So even I
Yes.
can apply ln as well. So I'm going to cover that in the next slide as well. So I just wanted to highlight कि यहाँ पे LG की जगह you could apply ln as well on both sides. It's the same thing because the ratio is going to be the same. All right. Solve the inequality. 4 multiplied by 3 raised to the power of 2x minus 1 greater than 5. Okay. You can give your answer in terms of base 10 log. So your final answer should be in terms of log to the base 10. You don't need to convert it into a decimal value now.
Okay. So is it half times LG 5 over 4 divided by LG 3 plus 1?
G3 plus 1. Okay, let's find out. If I solve this now, my first step would be to take 4 and divide it on the next side. So I'm going to be left with 3 raised to the power of 2x minus 1 greater than 5 upon 4. This is where I'm going to take LG. LG meaning to the log to the base 10. Is this your first step?
Yes, sir.
Now, what will happen to this entire power of 2x minus 1?
What is that?
So LG 5 upon 4. Now, our task was to,
Divide LG
eh,
3.
our, yeah, I could do that as well. That's also fine. Or I could just multiply LG3 with 2x and LG3 with 1. So 2 times LG3x minus LG3 greater than LG5 upon 4. I could do this as well, right?
Yeah.
I can also take now LG3 on the other side to LG3x minus, so this is going to be LG5 upon 4 plus Lg3. What is 2 Lg3 in terms of log? I can take 2 as a power of 3 and I can make
Yeah.
it Lg9 times x. And if you see over here, I can apply the product rule of the log and simplify this as a single log
15 upon 4.
15 upon 4. Correct. Now x is greater than Lg 15 upon 4 divided by Lg9. The question says to leave the answer in terms of log, so I'm going to leave it right now.
Okay.
Can this be further solved?
Um, you're using the division rule?
Uh-huh. But division rule is not applicable when you have log in the numerator and log in the denominator. It was only applicable when log of a upon b tha. जब वो
Yeah.
inside term was in fraction, then you could have split it up as LGA minus LGB. But when you have logs in fraction as a fraction, log of a number divided by log of another number, that over here you cannot use division rule. Make sense? There's a difference now.
Okay.
Okay. Is it clear, or do you want to try one more question?
Oh, so can I try one more question?
One more question. Okay. Just a second. Okay. You can try this one now.
So can you go to the slide before this just for 1 second?
Sorry, could you repeat your question again?
So could you go to the page before this just for 1 second?
Yeah.
Thank you. Oh, so it's fine, thank you. So I got LG 15 over 2 over LG 10.
Okay, and what is the decimal value?
I'll just calculate that. 0.8751.
Your answer is coming 0.8751. And x less than equal to or greater than equal to?
Greater. Oh,
Greater. Greater or less?
so less.
Less. Okay. Now let's compare your answer with mine. The first step that I think is will be this 3 upon 2. Then I can take log on both sides. The power is going to be shifted as a product over here. This will make it 2x plus 1 times Lg5 less than equal to Lg3 upon 2. 2 2x multiplied by Lg5 plus Lg5 less than equal to Lg3 upon 2. I can write this as Lg3 upon 2 minus Lg5, and over here I can write this as Lg5 square times x. Is this stuff here? 2 times x times Lg5 can be written as Lg5 square times x, or x times
Oh, so that's
Lg5
where I
square.
went wrong. I made LG 5 square, LG 10.
Oh, okay. So this is going to be Lg25. Yeah. And 3 upon 2 minus Lg5 will be 3 upon 10, right? And if I divide this further, Lg 3 upon 10, which is Lg 0.3, divided by Lg 25. So what is your final answer coming?
Minus 0.374.
Lg 0.3 divided by Lg 25.
Yeah.
Okay, let me check. Minus 0 point.
374.
Okay, minus 0.374. All right. Yeah, I think that is the right answer then. Okay. Do you want to try one more, or it's fine?
No, I'm fine.
Okay. So I have one more question for you. Let's say if you were given this solve 5x square greater than 2 raised to the power of x, and you want to give your answer in terms of logs. How are you going to do that? What is the first step that comes to your mind?
Apply log on both sides, or first put the do the power rule.
First, you will have to convert this into a log form to apply the power rule. The power
Yeah.
rule was applicable on the log. So this x square is going to come over here. This x can come over here. So you can write this as x square times LG5 greater than x times LG2. So far, so good.
Yes, sir.
Then what are you going to do?
Um, you can bring the X to the left side and the LG to the right. LG5 to the right.
So what you are trying to say is that bring this value of x as as a as a denominator over here,
Yes, sir.
and then you are planning to simplify x square upon x as x.
Yes.
Now you don't. It's not a good practice to do that step when you have inequalities. जब equation होती है तो ठीक है ये समझ में आता है. But when you do this when you have inequalities or let's say in trigonometric functions as well जब आप ये करती हैं तो the one of the value of x is gonna miss out. I'll show you. You can take x lg2 to the other side, and this is gonna give you minus x lg2 greater than 0. Now you can take x common. This is the right way to go about this question. X, if you take x common, you are going to be left with x lg5 minus lg2 greater than 0. Okay. Now it's it's a quadratic equation because LG5 represents a value, LG2 represents a constant value, x times x squared. So ये quadratic inequality है. And if you find the critical values वो roots होते हैं जहाँ पे the quadratic equation is going to intersect the x-axis. Okay, I'm referring these values to be the critical values. तो जब मैं इस इक्वेशन को सॉल्व करके क्रिटिकल वैल्यूज निकालूंगा आई एम गोना गेट x as 0 and x as lg2 upon lg5. सही है. So this means what is lg2 upon lg5? Is it a positive value?
I'm just calculating. Yeah, it's 0.431.
Yeah, so one is 0 and one is lg2 upon lg5. The question says give your answer in terms of log, so I'm gonna keep it as it is. Do you understand what am I referring to critical values as? I'm referring critical values to be the x-intercepts where the function value is 0. So if this is a quadratic function and I have been asked to solve for quadratic inequality, मैं पहले critical values निकालूंगा by considering them to be equal to 0. These are the two values. These are the two critical values. Now, if you remember a P1 quadratic chapter, you had solved quadratic inequalities in P1. उसमें ये करना था कि you want to give the range of values of x where this holds true, meaning your quadratic function is greater than 0. So if you remember, your quadratic function is greater than 0 at this side and over here, because uske beech, if x value is between 0 and lg2 upon 5, the value is negative, the y value is negative, the value of the function is negative. You want the function ki value to be greater than 0, meaning positive. So the so what is going to be the range of the values of x? If your value of x is less than 0, you're going to get a positive value greater than 0. And if your value of x is greater than lg2 upon lg5, you're going to get a value greater than 0. So as an inequality, this is going to be your final answer. Is this confusing?
No, sir, I get it.
You get it? Do you recall the quadratic inequalities that you have done in AFP1?
Yes, sir.
All right. Note this down. Let me know if you have any questions.
Okay. Yes, I have it down.
All right. Now let's have a discussion on the natural log. We refer natural log to the base 10 was just log to the base 10. But the name given to a log to the base e, okay, is known as ln. If you have log to the base e of anything, let's say a, then log to the base e is symbolized or written as ln. It's called a natural log, and e basically is an irrational number. E basically is an irrational number having a value of around, if you take this value out from the calculator, 2.718. And the function y equals to e raised to the power of x is called the natural exponential function. आपको याद है we were doing y equals to 10 to the power of x, y equals to 3 to the power of x. All these are exponential functions. So e also denotes a number, and e raised to the power of x is known as a natural exponential function.
Okay.
And if we convert this, okay, if let's say this is the equation given, and if I ask you to convert this to the log form, what is the log form going to be? You would say log to the base e of x, right? So log to the base e. So if you convert this natural exponential function to the log form, that is known as a natural logarithm. So log to the base e of x is called natural log function or logarithm. So consider these two equations, y equals to e to the power of x and y equals to log e to the power of x. Now I'm going to write log e to the power of x as ln. So I'm going to replace this with ln. Ln is always to the base e. Okay. When I write ln, I mean log to the base e of x. Now these are the inverse functions of each other. That's why their graph is always going to be a mirror image in the line y equals to x. If I draw e to the power of x, e to the power of 0 is also going to be 1. And this is y equals to e to the power of x. Let's assume this is the line of y equals to x. So the graph of ln x is going to be the mirror image of e to the power of x, the graph. You need to draw the reflection of this graph in this line. So this point, which refers to 0 comma 1, is now going to be 1 comma 0, and you need to draw the shape that looks like the mirror image, something like this. So this is the graph of ln x. Is this story clear?
Yes, sir.
Okay. So even if I wanted to solve this inequality, which one? Let's say 2 raised to the power of x greater than 3. If I plan on solving this through applying ln, I can do that. 2 to the power of x greater than 3. If I apply ln on both sides, because ln is to the base e, or let's say, we usually apply ln when we have a natural exponential function. For example, let's say e raised to the power of x is greater than 3. So if you're asked to solve this equation, solve this inequality, you can apply ln on both sides. So x is going to come over here, x multiplied by ln e greater than ln 3. And do you know what is ln e going to be? Ln is already to the base e of e. So the answer is always going to be
One.
1. So x times 1 is x, x is greater than ln 3. That's the exact answer. If the question is asking for the exact answer, we go for that. If the question says give your answer in decimal or up to some significant figure, some decimal places, then you can convert this answer. Is this logic clear?
Yes, sir.
Okay. Then please solve this question. E to the power of 5x minus 2 less than equal to 35. The question also says give your answer in exact form. Give your answer in exact form, meaning ln form or log form.
So I'm not sure how to do this one.
All right, let me help you. So since we have a natural exponential function, it's better to take ln. So I'm gonna apply ln on both sides. E to the power of 5x minus 2 ln of 35. Then this power can go on the left hand side, and you are going to get 5x minus 2 times ln e less than equal to ln 35. Okay, can you solve it from here now?
So this is where I got stuck because do we just leave it as 5x minus 2 because ln e is 1, right?
Ln e is 1, so 5x minus 2 ln 35. Okay, so 5x is less than equal to ln 35 plus 2, and then x is
Upon.
going to be 2 plus ln 35 upon 5. Okay,
Yeah, that's what I got, but I wasn't sure if it was right.
all right. Is it clear now?
Yes, sir.
Okay. Okay, try this one and give your answer to three significant figures. So this is a log equation given to you, and in order to solve this, you will have to convert this into an exponential function. How can I convert this into an exponential function?
E to the power.
Yeah. So since I know that ln is always to the base e, I can write this as e raised to the power of 6 equals to x minus 2. So x is going to be equal to 2 plus e raised to the power of 6. And then you can find the value from the calculator to three significant figures.
405.4.
405.4.
4.
So in three significant figures, it is going to be 405. All right. Okay. Yeah. ln 2x plus 1 is equal to minus 2. I want you to give me the answer in exact form, not the decimal form.
Okay. Is it minus? Oh, sorry. E to the power of minus 2 minus 1 and the whole thing divided by 2.
Yes. So e raised to the power of negative 2 equals to 2x plus 1. Now, e raised to the power of minus 2 can be written as 1 over e square if you want. 2x is going to be 1 upon e square minus 1, and x is going to be half times 1 upon e square minus 1. All right.
Okay.
ln of 3 minus x square is equal to 2 ln x. Give your answer to three significant figures. Okay, so what is your first step?
I multiplied ln by 3 and minus x squared.
You have multiplied ln by 3,
Yeah,
but we never multiply ln because ln itself means nothing. Ln of a number means something. So this is entirely one unit. Ln 3 minus x square is one number, one
yeah,
expression, one term. Okay, so we don't multiply this. Now, what you should be doing is, first of all, you should take this 2 back as a power of x. So ln of 3 minus x square is equal to ln of x square, right? Can I say that?
yeah.
Okay. Now, ln of something on the left is equal to ln of something on the right. If they are equal, can I say that 3 minus x square is equal to x square?
Yeah.
Therefore, 3 minus x square is equal to x square. Then 2x square is equal to 3. X square is equal to 3 upon 2. And then x comes out to be equal to,
Plus minus 3.
which comes out to be,
2, 6, and 2.
sorry, what is the decimal value?
1.225.
1.2247. I'm getting 1.2247. So in three significant figures, it's going to be 1.22. And should I be writing plus minus, or is the answer just going to be plus?
Plus minus. Oh no, it's only going to be plus because it's ln.
Yes, yes. So ln of a negative number is not defined. Okay, so that's why we are only going to take positive 1.22 as the final answer. Should I give you one more question like this?
Yes, please.
Yeah. What is the first step that comes to your mind?
Mm, Just square to
I can take this 2 as a,
power.
yes, power. So this is going to be ln of x plus 2 square. Now, how do you plan on simplifying this? The two logs to the same base e are being subtracted. Could you remember some rule?
The quadratic.
The division rule. So can I say that this is equivalent to ln of x plus 2 the whole thing square upon x? Can I say that?
Yes,
Is it confusing or you get it?
I get it.
Okay. So after applying this law of log, the two logs on both sides which are to the same base e, ln of this number is equal to ln of this expression. So I can say that the two expressions are equal. So x plus 2 the whole thing square upon x must be equal to 2x minus 1. So from here you can get a quadratic equation which you solve will result in the value of x. Are you getting the same quadratic equation?
Yes, sir.
Now, what are the values of x?
Just like that. No, sir, I'm getting a different one.
You're getting a different equation. Were you
Yeah,
getting same expression on the left and on the right when I begin this slide?
yeah.
X. Okay, so I just multiplied this x with the right hand side. This gives me 2x squared minus x, and then I expanded x plus 2 the whole thing square, which resulted in x squared plus 4x plus 4.
Okay. So the answers are 5.7 and minus 0.7.
5.7 what?
It was just
5.701.
5.701
Okay, 5.70 and
and 0.701.
0.701. Is it negative or positive?
Negative.
Negative. Okay. Now, so I'm gonna go back to my question and I'm gonna see, is the value of negative acceptable? No, it's not going to. It might work over here. It might satisfy this log, but it won't satisfy this log at all. So yeah, only one answer, that is 5.70. This is the answer. Okay, let's try another one. ln of 2 plus x square equals to 1 plus 2 ln x. You can discuss your first step with me if you have any doubts.
Okay. So I'm confused what to do with the one.
Exactly. So, what was your first step? Did you take 2 ln x to the next side
I made it ln x square.
and then you took ln x square to the next side?
Yeah.
Great. So then, how would you simplify the left hand side? If you have two logs that are being subtracted, then what rule that comes to your mind?
A division.
The division rule. Okay. Now, are you stuck over here? Did you get stuck at this point?
Yeah.
All right. So whenever you have a single log in an equation, in order to solve this, you can convert this into an exponential equation. So I know that ln is to the base e. So e raised to the power of 1 is going to be equal to 2 plus x square upon x square. So 2 plus x square is equal to ex square. If I simplify this further down, ex square minus x square minus 2 equals to 0. I, I can take x square common out like this. Since I want to, e minus 1 will just be a number, okay?
Okay.
So x square is going to be 2 upon e minus 1. E minus 1 was being multiplied on the left hand side. On the right hand side, it can be written as a denominator. X square is going to be equal to 2 upon e minus 1. Now, if the question says to give your answer in exact form, you give 2 upon e square minus 1 square root. But if the question says correct to three significant figures, then you can evaluate this answer from your calculator. Give your answer to three significant figures right now.
So why is it e square? Why not just e?
Yeah, my bad. Sorry. This is going to be e raised to the power of minus 1.
1.079.
So 1.08 is the answer to three significant figures. Now you can note this working down before I move on to the next question. Are you done?
Yes, sir.
Okay. Okay. Now the question says express y in terms of x for each of these questions. Part 1, 2 ln y plus 1 minus ln y equals to ln x plus y. We need to express y in terms of x, meaning we need to make y the subject. Okay.
Okay.
So what will happen to this 2 over here?
It'll square, become power.
So it is going to be ln of y plus 1 the square minus ln y as it is ln x plus y. All right. Now the two log to the same bases are being subtracted, so this result would be simplified to Can I write it like this?
Yeah.
Now, if the two logs on the left hand side and on the right hand side are equal, can I just equate the inner terms?
Yeah.
Okay, now I want you to simplify this, solve it, and make y the subject.
Y equals to minus 1 over 2 minus x is what I'm getting.
Y equals to,
Minus 1 over 2 minus x.
so yeah, that's correct. I think that's correct. Y plus 1, the whole thing square is going to be xy plus y square. If I expand this, I'm going to get y square plus 2y plus 1 equals to xy plus y square. Y square would be cancelled out. 2y minus xy plus 1 equals to 0. If I take y common out, I'm going to get 2 minus x equals to minus 1. Either I can write minus 1 upon 2 minus x, or if I take minus sign common from the denominator, I can write 1 upon x minus 2. Same thing, okay?
Okay.
Okay, so should I move on?
Yes, sir.
Let's do another part for the same question. ln y plus 2 minus ln y equals to 1 plus 2 ln x.
So I'm not sure what to do about the right side.
On the right side,
Mm.
okay, so the first step that I could think of is to
Put
simplify
it-
the left hand side, and I can write 2 ln x as
Yeah.
ln x square. Then ln of y plus 2 upon y minus ln x square equals to 1. This could be written as ln of y plus 2 upon 2 divided by x square. Would you agree with me?
Yes.
Okay. Now, since I have one log left in the equation and I need to solve this log equation, that's only possible if I convert it into an exponential form. So e raised to the power of 1 must be equal to all of this y plus
What
2.
happens to the y that's being divided by y plus 2 in the step before this?
Yeah, sorry, y plus 2 is being divided by y. Is that what you mean?
Yeah.
Yeah, I made a mistake. So y plus 2 upon y divided by x square equals to e raised to the power of 1. Then this is going to be y plus 2 divided by y x square equals to e to the power of 1. Remember, I need to make y the subject. So this is going to be y e x square. I'm going to collect all the y terms together. Y minus y e x square equals to, or I could write it as y e x squared, making this as positive, minus y equals to 2. If I take y common out, I'm going to get ex squared minus 1, which is going to be divided on the other side. So the equation comes out to be 2 upon ex squared minus 1. Is this question clear?
Yeah, so I'm just copying it down.
Sorry, what did you say?
I'm just copying it down. It's clear for me.
Yeah, sure. Let me know when you're done.
Yes, I'm done.
Okay. Okay. Solve, given your answer in exact form. A e raised to the power of 2x plus 2e to the power of x minus 15 equals to 0. I want you to try this one as well as e raised to the power of 2x minus 5 e raised to the power of x plus 6 equals to 0. Do you remember the strategy to solve these questions?
Do you use the quadratic equation?
Yes, that this looks like a disguised quadratic equation. I mean, I
Yeah,
cannot say that it's a quadratic equation right now because it's an exponential equation, but
yeah.
it it is like a disguised quadratic, meaning if I let y equal to e raised to the power of x, then for the first term I can write y square plus, then for e raised to the power of x I can write y, so that is going to be 2y minus 15 equals to 0. Now this becomes the quadratic equation, which can be either factorized or solve it through the quadratic formula. So what are the values coming?
I'm just calculating that stuff. 3 and minus 5.
3 and minus 5. Okay, 3 and minus 5. But I'll have to solve for x. Therefore, I'm going to replace y with ln. I'm going to replace y with e raised to the power of x again. Now, clearly, this is not possible because there is no value of x that is going to give me e raised to the power of x as a negative value. Remember the graph of e raised to the power of x? It was entirely above the x-axis. So I need to solve this now. How can I solve this further? I need to find the value of x.
You converted to ln?
Yes, exactly. So you apply ln on both sides and you are going to get ln 3. Now once you are done with this, you can try out with the second part.
Yeah, so for the first one, I got 1.099, and then for the second part, my answer is ln1, which is 0.
I want the answer in exact form for this equation. So if you let y to be e raised to the power of x, you're going to get y square minus 5y plus 6 equals to 0. I want
Oh,
you to give me the exact
minus
answer.
ln3 and ln2.
Okay, so what are the y values coming out? 2 and 3.
Yeah.
So e raised to the power of x is 2, e raised to the power of x is 3. Therefore, x is ln 2 and x is ln 3. All right, good. Now, one more question. Given that the function f is defined as, now recall your knowledge of functions that you have covered in P1. The only difference is that this time it's going to be an exponential function uh, for x belongs to all real values, and you need to find an expression for f inverse. Okay, so apply the same logic and find me the inverse. Do you remember how do you solve for inverse function?
Uh,
You replace f of x with y, make x the subject, and then interchange the value x
yeah.
and y.
So I'm not sure what to do in this one.
Okay, all right. Let me help you. So the first step is should be that you replace f of x. See, f of x is 5e to the power of x plus 2. So you replace f of x with y. Okay. Then you need to make x the subject. Would you like to try from here now?
Yeah, sir. After sending 2 to the other side, I'm not sure what to do. Do I apply ln?
Yes, that's correct. So e raised to the power of x is going to be y minus 2 upon 5.
Oh, okay.
So as a final step, what is going to be?
Ln y minus 2 upon 5.
Yeah. Therefore, inverse function is going to be ln x minus 2 upon 5.
Okay.
Oh, okay.
Yeah.
Yeah, I think I've covered everything for today.
Okay.
Now, in the next class, okay, before coming to the next class, please revise all of this. And
Yeah.
in the next class, I can start with there's one thing left in this chapter that is transforming a non-linear function into a linear function. So yeah, that's pretty much about this chapter. So in the next
Okay.
class, I'm gonna cover that, and then we are going to start with the next chapter. Okay?
Okay.
All
Thank
right.
you, sir.
You're welcome. Love